Hi, folks. Today we're going to start with 5.3, identifying proportional relationships in tables and graphs. Tables can represent proportional relationships when all ratios of y to x are equal. Now, in case you're wondering, what is this y to x? Look down here at your graph. On the graph, notice you have an x-axis and a y-axis. That is where your x and your y are coming from. Excuse me. Now, what we're talking about, the table can represent proportional relationships when when all the ratios of y to x are equal. Notice how 2, 4, 6, and 8, they continue to rise by 2. And notice here, each one of these change by 2. So they're equal. Look over here on this next one. 1, 2, 3, 4. Each one of those changed by 1. Down here, it changes by 2.5, and then 5, and then 5. But notice those aren't equal because that 2.5 throws it off. The ratio of y over x, written as a unit rate, is called the constant of proportionality. Constant of proportionality, or rate of change. We use the letter K to identify that. To find the constant of proportionality, we divide y by x. And then write that answer over top of 1. The point 1, r represents the what? What do you think 1, r would represent? Unit rate. Because remember, when you're in your coordinates like here, this is x and that is y. Remember that you write it as y over x, and if x is equal to 1, then any y over top of 1 is your unit rate. Because unit rate is x to 1 or a to 1, whatever it is, it's over 1. Now, let's look at our first example. Grandma's famous chocolate chip cookie recipe calls for 3 cups of sugar and yields 2 dozen cookies. Find the constant of proportionality and graph the table. What do you notice about the proportional relationship demonstrated on the graph? In order to find this, let's take what's given to us. Let's take what we know here. If we have 3 over 2, what would be this rate over 1? 3 over 2, we have y over 1. We want to find the y, so you'd have 2y equals 3 because you cross multiply. 2 divided by 3, y equals 1.5. Now, what would that be for 4? What do you think it would be for 4? How would we find it? If we don't have anything here, what would we do? You could set it up a couple of different ways. What you could do is x over 4 is equal to 1.5 to 1. And if you cross multiply and divide, you have 1x, or just x. X is equal to, and what is 4 times 1.5? You'd have 6. Okay? Or you could simply take, say here in this example, 6 times the unit rate to 1. What's 6 times 1.5? 6 times 1.5 is 9. 8 times 1.5 is 12. And 10 times 1.5 is 15. Now, that process only works if everything's equal and it's proportional. So, excuse me, let's graph it. Remember, your coordinates are x to y, so 1 and 1.5. But first, we need to identify our numbers down here on our axis. So we're going to go 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, 16. All right, let's graph. I'm going to have 1.5 to 3. Our next one is, oh no, I'm sorry. Oops, let me back that up. We got 1 and 1.5. So 1 to 1.5. And then we're going to have 2 to 3. And then we're going to have 4 to 6. 6 to 9. 8 to 12. 10 to 15. And what do you notice? What do we notice on our table and graph? First off, it has a straight line. Everything's rising equally. And you have a equal ratio on the tables. But lastly, on the graph, you have this. Notice where that crosses on the table. If your line is straight and it crosses at 0, 0, or the point of origin, your graph is proportional. So 0, 0, point of origin. You have to cross through 0, 0, or the point of origin, and have a straight line, and you can be proportional. Okay, let's try one more. The following table shows the amount of candy you can buy. Excuse me, sorry. The following table shows the amount of candy you can buy for each price at Sweet Treats Candy Shop. Analyze the proportional relationship and fill in the table, and then graph the points. So, notice we've been given some information, right? We can use that to find the rest. What would be the unit rate? How could we find the unit rate of price to candy? If we know it's $5 to 2 pounds, we can divide the top by the bottom and we can find the unit rate. And that should be 2.5, because 5 divided by 2 is 2.5, and that would be over 1. That would be your unit rate. So $2.50. Now, let's look let's look at the information that's given to us. Does each one rise by 2.5? Well, for the 2 pounds, it does. What about for the 3 pounds? Yep. 5 plus 2.5 is 7.5. What about for 4 pounds? Yep. $7.50 plus 250 is 10. What about for the 5? Yep. So it's showing everything proportional. Now, remember, take your amount, your x, remember this is the x and this is the y, and multiply it to the unit rate, or K. And that will give you that will help you fill in this blank here. So 6 times $2.50 gives you what? Gives you $15. And 7 times 2.5 will give you $17.50. Now, remember we have x and we have y axes. We need to label these. 1, 2, 3, 4, 5, 6, 7, 8. Now we need to label our sides. How would you like to label the sides? We can label our sides in the money, right? So let's go to 250, 5, $7.50, 10, $12.50, 15, $17.50, and then 20. Now, all we have to do is graph. And as I'm graphing this, what do you notice about the dots and the line that they're making? So, what does the 0.1 and 2.50 represent? That represents the unit rate, right? That would be unit rate, or K. And the constant of proportionality is what? It's $2.50 to 1. Same as the unit rate. Now, is this proportional? It is. Why is it proportional? Yep, it goes through the point of origin, 0, 0, and it's a straight line. So it is proportional. All right. So take a moment, review a little bit, and then go ahead and start your exit slip. I'm going to cut this one short because our last video was super long. So I'll try better at making the videos a little shorter for you guys. Anyway, take a moment, review if you need to, and then try your exit slip. If you have problems with it, let us know. We'll get with you and cover that. If you pass your